Let's create a linked list using structs and local variables. If you're new to linked lists, watch my video on them. We'll start by making a struct. A struct is a reusable template that describes the layout of a group of values. We'll name this struct node. It will contain a value and the address of the next node. We set the size of struct's properties the same way we set the size in the BSS section. We'll reserve one keyword for both of the properties. Let's take a look at a node in memory. The first 8 bytes will contain the node's value, and the next 8 bytes will contain the address of the next node. This means that for a node located at address 12, the node's value property is located at address 12 and the node's next property is located at address 20. In other words, the value property has an offset of 0 from the node's address, and the next property has an offset of 8 from the node's address. The labels of each property in a struct are equal to its offset from the starting address of the struct, so node.value is equal to 0, and node.next is equal to 8. Later on, we will access the node's properties by adding the offset of the property to the node's address. Let's set up our program like normal, and then move the value of the stack pointer into RBP, or the base pointer. We will be storing local variables on the stack, which are basically variables that exist until the current subroutine ends. Saving the stack pointer allows us to quickly delete the local variables once we are done by moving RBP into RSP at the end of the program. Next, we'll subtract the size of 2 nodes from the stack pointer using the subtract command. This essentially reserves room for 2 local variable nodes. NASM provides a constant for each struct that is equal to the size of the struct in bytes. The constant is always the name of the struct, an underscore, and the word size. To create our first node, we will move the value of the base pointer into RDI and then subtract the size of one node. RDI now points to the first node in memory. We'll set the first node's value to 1 by moving 1 to the address of the first node plus the value properties offset. Because the stack pointer has not changed since we last manipulated it, we know it holds the address of the second node, so we'll set the first node's next property to RSP. For the second node, we'll subtract the node size from RDI again and set its value to 2. Because there are no other nodes in the list, we will set the next property to a null pointer. We'll end our program like normal.